It is 3 o'clock. Thank you guys for sticking around. Are you all still conscious after those massive cupcakes? That was a tough one to get those down, but they were wonderful. So I'm real pleased to introduce one of our sponsors here for the event here, Maarten Masschelein. Pretty close. He has been, he's the founder and CEO of Soda, and so because I like Diet Coke, I thought that's probably a good straight to start, but we'll get all that. The real key is the idea of trusted data, and if you can create observability around data, it makes everything more transparent. Maarten, I'll just turn it over to you and let you go.
Thank you so much.
Thank you.
Hello, everyone. Thanks for being here. My name is Maarten. So I'm one of the co-founders of Soda. We're a company that's been in business for about 4 years now, so it's relatively new. I personally have a kind of business engineering background, and prior to starting Soda, I spent almost 7 years at a company called Colibra from 2011 onwards. So that was, I think, before we had our first official CDO. So those very early days. I love data. I have some data to share today, so we can look at that. I also love classic cars. I have one car, which is a Fiat from '77. I love it to that, and I love cooking as well. So if you don't find me here, you'll probably find me in front of a big paella pan making food for a large group. So that's a bit about me. The company, what we focused on from day one is take an entire fresh look at this space of both reliability and quality. And it was all about the idea of bringing as many people involved in that process, make it easy for as many people as possible, and create the observability that teams need to really understand what's going on so they can stay on top of data. And the key kind of workflow that we focus all our attention to is discovering, analyzing, and prioritizing data issues. So that's the core of what we do as a company. And I want to start with a question. And we're not using the poll, but I just want to have you think about, like, what is this number, maybe for your teams, or what percentage of time are data teams at your organizations today spent? How much time do they spend on handling data issues? Sorry? 70, 80? That's 90. Wow, that's a lot of time. We did a survey at both Snowflake's and Databricks conference in the last couple of weeks. We surveyed about 90 individuals, a mix between business subject matter experts, data stewards, and data engineers. And the number that they came up with was 35%. The median was 30. The maximum amount that they responded was 60. So that's from practice. Again, that's from all of those, but I guess I think we all know that there's an awful lot of time being spent into firefighting and handling problems reactively, and that creates a lot of frustration. It's not a great experience when you join a data team at a company and everyone's firefighting, and it creates a lot of stress, and you're not really advancing as fast as you're hoping. So for the overall employee experience, it's also not a great sign. So that's really the number that we focus on. How can we reduce this? Can we make data teams as proactive as possible, give them the information they need to figure this out as early as possible so that there's no downstream or limited downstream impact. That's really the core of what we do. And very briefly about the company, we're not going to spend all too much time on that, but we're about 40 people. We have some amazing customers. Whenever I personally have a bad day, this is the logo wall that I look at. Makes me smile every time. There's many more, but we're fortunate to be able to work with companies that have advanced data teams, have a lot of experience. Some companies that we work with have engineering teams in every business unit, which is also a unique experience, I think. And a part of our software we've also made available in open source. We'll talk a little bit about that. But open source is something entirely new for me, not new for my co-founder. He's done open source initiative projects in the past. Actually, how I met him was his open source software was the workflow engine for Colibra software for all data stewardship workflows. So that was the underlying technology, and that's how we connected. But open source has been a very interesting journey for us because we've developed tools specifically for data engineers, only data engineers in open source, and that's been going very well. We're at 35,000 downloads per month right now, and that still keeps on growing rapidly. We don't know how many companies that is. It's a mystery, but that comes with going into open source. All right. I think this is preaching to the choir, but I'm going to do it quickly anyways. So why is it important, right? We've talked about productivity and morale earlier, about the kind of employee experience. The key thing is if you have a lot less data quality issue or are more on top of them, you'll be able to deliver faster on data-driven initiatives, which I think all of you have plenty of. So just about speed and agility. When engineers are stuck firefighting, they cannot work on new things. That's kind of that's the premise. So they have to balance, on the one hand, speed and agility with stability as well, and that is not an easy equation. Not easy for them to balance, but it's very important to keep that top of mind also when managing engineering teams. The great customer experience, well, that's direct top-line impact. If you have data products or features that are customer-facing, if they're not working well, that has a direct top-line impact. I think we all know examples from e-commerce. I think that's where we saw a lot of those very early on, where issues in data resulted into issues in recommendations, which resulted into a lot of lost revenue, unfortunately. And then regulatory is always top of mind. Regulations are not going to go away. So the more structure you have around these processes, the easier you comply. That's my top 4. I'm sure there's more. So that's why we believe it's very important. Not going to go all too deep in the types of issues because this is only a subset of them. But these are very often recurring types of problems. This is based on research from Google and a whole bunch of other companies, all aggregated into one list. Again, there's more, but just to name a few, inconsistencies in data over time, schema changes. That's so many problems nowadays because we're relying on external feeds of data, and there's a small change that happens. It's an undocumented or uncommunicated change, and before you know it, it has your revenue reports are not adding up because maybe Google added a new code in one of their payment types, which you filtered out right at the beginning, which is good practice, but then you don't know about it, and all of a sudden your numbers don't add up anymore. And there's many more. This list I don't think is a very helpful tool to look at. I like to look at it more from a overarching kind of workflow process. So if we kind of simplify the entire structure, we have data producers, whether they are internal business teams, external third-party vendors. You have your engineering teams, typically either data engineers or analytical engineers or analytics engineers, and then your consumers, which are typically either BI or machine learning. So it's a bit simplified, but that helps me usually to think about this a little bit. And from the producer side, not all data being there, data not being fresh or on time, and again, structural changes, new values, new columns, schema changes, they're the most common problems on that side. And then as you bring it into the engineering world, so as you ingest and transform that data, jobs fail. All of a sudden, or even worse, jobs pass, but no data went through. That also happens, and you don't necessarily see it if you've not designed or architected for that. SQL bugs, like most data transformations today, are written are done in SQL. DBT being a good example. It's very easy to introduce bugs in SQL, unfortunately. And especially as we see data engineering teams adopt software engineering principles, they will start releasing much faster. Every new data transformation pipeline can get a code update or release multiple times a day. And before you know it, you've introduced a bug and the data looks very different for your downstream consumer. And one that we last week personally came across, which is some databases truncate. So yeah, you lose data, but then you don't even know it's happening. It's just a limitation of the database. These things just happen, unfortunately. And for the consumer, it's broken dashboards, incorrect data, unstable models. Your machine learning engineers might be focused on figuring out why your prediction is less accurate. Well, it's sometimes the data. It's actually quite oftentimes the data. So having more processes and structure and operations to handle this, but also dividing and conquering this problem, because you cannot do this alone. Like, you cannot do this in isolation in a certain team. You need to do this really with your entire data team. What are some common approaches? I think the one on the left is probably for everyone a no-brainer. That's critical data elements type of approach is very popular. I was first introduced to it within the financial services context about 10 years ago, if not longer. But it's ultimately a very good way to prioritize. So what are my key data elements? You look at it from a variety of facets, whether it's for regulatory, internal reporting. There could be many different ways in which you want to prioritize, but stack ranking those, gathering requirements, and then setting up SWAT teams or teams to go and fix is a very helpful way. It's a top-down way. It's typically data governance kind of oriented or led and by the business. Whereas what we see with engineering teams, especially like a lot of the engineers that come from software engineering, well, they've done testing for data for a long time. They've created observability on their infrastructure layer, on their application layer for a long time. So they are doing the things already today. You see huge adoption in data engineers just, for example, start testing data. They do that on their own because they feel it's the right thing to do. And not only that, it also helps them because they're often on call when these problems happen. So they want to avoid that as much as possible. So they have a very good incentive to start doing this. So they test it, and their approach is slightly different. It's more bottom-up. When they build a new data product, they will start adding some code to test and validate data. They will start capturing information about this process, which could be, for example, logs. You can have your logs from Snowflake or your data warehouse to help debug the problem. Or they will capture metrics, data health metrics. For example, capture the freshness of data each time it refreshes, plot that on a time series anomaly detection and figure out if anything is incorrect or wrong. And that's kind of more of their way of going about this. And these two approaches I think they're very helpful. But they require more, I guess, meat to the bone. Like, there's more work to be done here. There's more operational workflows and processes to put in place to bring all of these initiatives and people together. And that's, I think, the second part of what I want to talk a little bit about today is what is kind of the evolving role of both of these personas. And this is subjective. It's based on our experiences from working with these teams. Where we find it's very helpful for engineering teams to focus on is on improving what I would call data reliability. And reliability is a property really of a system, right? Will it perform its intended task over time? It's designed to do something, and will it actually keep on doing that over time? That's something very much contained. It is things that all the data goes into your data platform, the transformations, and then kind of that's the spectrum for the data engineer. very oftentimes today, unfortunately, they're pulled into conversations that they absolutely can nothing do about, which are record level problems with data that come from the source. They cannot do anything about it, but they can focus on reliability. So reliability, how do they best do that? It's by creating that data observability. This concept is, I think it's definitely not new. It's an old concept, observability, but it's newer in data. It talks about how much is a system really, it's a property of a system, how much is that system making information about what's happening in it available for others to understand really the health of it. Right, so you could say that a log output of Snowflake is observability data, right? Because you can go and see what went wrong. And it's about how can we present that information in a palatable way, an easy way to consume to help debug the problems much faster. And data testing is very nascent, but a huge area that we're still very early. Like our open source product solely focuses on this, and I'll show you in a little bit some examples. We'll walk through setting up some tests and checks on data. We'll test them, we'll put them in production. We'll do that just in a couple of minutes, so it's very easy to do. But it goes beyond just data in production. You need to be able to test also when you release new analytics codes. So, for example, comparing staging to production. If I now push this change, how does that impact my data set? And is that a change that I expect or not? So we know these concepts in test-driven development from software engineering, it's already from the 90s. So we never looked back. Like engineers adopted them and they're like, wow, we need this and everyone's doing it. But for data, it's still very early. But integration tests, smoke tests, unit tests, like there's loads and loads of learnings and things that we can take from software engineering and bring that into the data engineering world. And that's part of the focus of our company, especially when it relates to the value proposition towards data engineers. For the business, and this might be, we'll see if this is more controversial or not, but I strongly believe that as a data producer, I think many companies or organizations have already adopted this notion that if you publish data to everyone, it needs to be well defined. You need to have your definitions, your information about data ownership, so that people can kind of go search and find it. That's key. But what is not commonplace yet is that you will publish this alongside an SLA of what are you actually going to do, or what are you guaranteeing that this data will do for your consumers over time. That's not common today. Correct me if I'm wrong, but I haven't seen it very often yet. And I think it's a very good idea. It's a very good thing to do. In data management, I think traditionally we've talked about data sharing agreements probably already 20 years ago, if not longer. That's before my time. But they were usually just documents that we write about what actually needs to happen without having automated ways to go and check this or validate this. And this is something we'll do in a bit. We'll create a data sharing agreement, go through that process, see how that works. But we've invested a lot in making that workflow something you can implement like this within your organization. It still will require a lot of change, right? Because you need to train everyone and to follow this process, but they'll very quickly, because how simple it is, they'll very quickly see the benefit of it. That's the responsibility of the data owner, so very often the data producer. Another workflow that is very helpful to introduce is when a consumer is building a new data product. To actually go to your data owner and say, well, this is what I'm going to do. And this is key for me that remains stable over time. I need this data refreshed every hour with this amount of, the freshness needs to be less than a couple of minutes. I need these and these columns to be fully complete. These need to be standardized values. These need to be reference checked against another table. And if all of that holds, I'm happy. That is something, that conversation is very often not happening today, which results in producers absolutely have no clue about how data is used further downstream. And it's very often, like in the current way of working, very often like tools like data lineage, et cetera, are used for this, but they're not very helpful. They're very complicated. It's actually much better to have your overview of all your core data usages, having the controls on those, And that helps you then prioritize. And that brings me to the next point. The final workflow is having a lot more clarity around prioritization of problems. And today it's very hard to understand if something breaks in this table, who's impacted downstream? Like, and is that fixing that problem more important than another one here? How do we do that? And I think having that context of these usages, and it's not something we can enable for everything, right? Retroactively, it's something we need to implement as a process going forward. But once you have it, you'll have much more clarity around which problems to solve first. Very cool. This is, we're going to go a bit slowly into more of a demo mode, make it a bit more about product and implementation and how we can go about this. Not sure if it's common to already ask questions, but if you have, don't hesitate. But otherwise, at the end, we can do them as well. I'm going to zoom in on one specific, so it's aligning on data expectations. This is a visualization that we've made that I think is quite helpful in understanding kind of where these expectations or these alignments on these expectations or what we call agreements, where that makes sense. So here we have an example of 2 domain teams. You can see them as business functions, or you can see them as true domains. Now, it doesn't really matter, but they're 2 different teams, typically with different managers in the organization. And we're building a product. It's somewhere, it's on the bottom there. So is a, oops, I was afraid this would happen. On the bottom, we see the data product that we're building. And, on top, which goes to your decision makers. And we have 2 data sets, one that is generated or created within the business unit or the domain, and one outside. I think you can guess where most problems will occur. It's usually the one that comes from outside, because there's a lot less communication typically, a lot less, these teams are typically a bit more disconnected or siloed, especially in larger organizations. So it's a very, I think, helpful approach to, on both of these usages, have an agreement. Agreement that constitutes what's really required. So, and of course, maybe important to add as well, the agreement, it's one of the key things really is, it's an agreement. So your data owner, the person producing the data, needs to accept it. And accepting it means also handling the problems, which is, and creating visibility around how much effort that is, and having more communication around that. And that is, I think, it's one of the most important things. Otherwise, in these types of systems for quality and reliability, you create loads of alerts, fatigue, lack of ownership, and ultimately a failed initiative. So I think this is really the key point. All right, we'll go into an example. So this is gets a little bit more technical, but hopefully that's fine. This is a domain-specific language that we've been brewing, that we've been creating for quite some time. Sure?
How do you define a domain?
As in, how do we define a domain?
I don't care who you define it. How the customer define a domain?
Right. So how do you define a domain?
How does the customer define a domain?
As in, how do they think about organizing their businesses in terms of domains, or?
Yes.
Well, it comes from domain-driven design, I think, is one of the influential pieces around this. It's a logical grouping, I guess, of a lot of subject matter expertise around. For example, if you think about Spotify, what would their domains be? I think they have a listener's domain. I think they will probably have a artist's domain. They might have a song recommendation domain. I think I'm not so an expert in how you organize by domains, but I do think it's something that typically transcends your functional silos within an organization and brings certain subject matter or domain expertise about a certain part of the business into one group or logical unit. I hope that. Is this a test? I could try again.
It's a knuckleball. It's a knuckleball. I don't know if you know what a knuckleball
No.
Extremely hard to hit.
Right. A curveball.
No.
Much worse. Got it. In the context here, DSL, domain-specific language, is it's a slightly other context, but that is SQL is too high level or too generic to solve this, too complicated. So in order to solve problems around quality and reliability, we've created a higher level language, a domain-specific one. Alternatives, like you might know HTML or CSS in web space, that's also a domain-specific language. But we really found it was necessary because the people in the business that actually know the data, they don't necessarily write advanced SQL queries. So how can we get those people to bring their expertise into this domain? How can we involve them so that data engineering is not a bottleneck? That was for us really the core. And we've worked with a lot of companies. We've hundreds of thousands of checks in place, I think. And they're a very wide range from, you can see a row count between 10 and 1,000, very easy. You can also do row count anomaly detection. You can do row count change over time, percentage or absolute, relative or absolute. Missing count on birth dates. We're not specifying what missing is, but we're saying no missing, which by default is nulls or NA or what have you. Invalid phone numbers, less than 1%. Valid formats, it's one that we already have, phone number. But you can also add the regex to it if you're a bit more advanced. And you can see how we're building up something that is actually very easy for somebody to learn and adopt. Maybe not to write like this in a text file. We need to have some augmentation around that, make it easier still. But it's a very easy way for less technical people or less, I guess, SQL savvy users to get involved in this process. Of course. Oh, we've got tools.
Chris, question. Sometimes it's very difficult to express it in numbers. Mm-hmm. Sometimes it's, especially if the data is coming from combination of devices and people. So the only way to express it is kind of in anomaly detection terms.
Yes.
How should we be thinking about that?
I think there's three key methods really that you can use. So this one, which I think all of these examples they're just declarative, like you tell the system this is wrong. And this comes from the known universe of problems, the things we know that go wrong, we just encode here. Or it comes from the knowledge of, well, these are things that create quality problems. So maybe we should proactively check for them. So those two areas are covered. There's two popular approaches today that involve machine learning. One is metrics monitoring. Metrics monitoring is pretty high level. It's great for data engineers. It ultimately, what you do is you collect a whole bunch of statistics about your data sets each time it refreshes. It could be the row count. It will be the freshness on date timestamp or datetime columns. It could be aggregates on column level. Could be, for example, how many missing values do we have in this column, etc. And then monitor that. And that you do with time series anomaly detection, which off the shelf, you've Profit from Facebook and many others. It's quite easy, and we have that as a feature as well. Now, and the third one is more unsupervised learning. And that is where, for example, each time data refreshes, you will, for example, look for functional dependencies within that data of when state equals New York, postcode is X structure or range or what have you. And then each time when these dependencies change over time, you will be alerted of that. And that is already a bit more advanced technique. Those are the three ones that I know. I'm sure there's more. The thing that I also have learned from experience is that the more you go to the right, the more alerts you create. So the more time it gets to analyze, and the trickier it becomes to make sure your operating model keeps working without any bottlenecks. So it's a bit of a trade-off, but there's definitely plenty of techniques to do this. Does that answer your question? Or? Awesome. Alrighty. Cool. This is the very last thing I'm going to briefly touch upon. This is just to give you an idea of how we have architected an application like this. So we've created what we call Soda Core. That is free, available for everyone. It's available on GitHub. So if you have data engineering teams that want to check it out, I strongly recommend to do so. Literally in half an hour, you start checking your data. It's very easy to do. Apache 2 license, you can build on it. So it's a fantastic way to get started. And the core function of this is to check and validate this Soda CL configuration file that I've showed in the previous slide on data, whether that lives on premise in a DB2 or in a more modern Snowflake, or whether you build your stack on Databricks and you use Spark. It works across all of these environments. The Soda agent is a wrapper around. This gets a bit more technical, but that creates an interactivity within Soda Clouds. And the interactivity is for the analysts. And I'll show you that example. Analysts can spin up scans on data by not having to do any infrastructure work. It's just there. They can do it from the user interface. And the cool thing in this is that we never move data. Data doesn't even need to move between regions, doesn't need to move to our clouds. Everything remains local, your computes, which is super important at scale and very important for privacy, security, etc. And then only the results of that are pushed into our clouds. And we're adding on Soda Core, we're adding a lot of scientific libraries now to do more of these machine learning driven approaches. We already have added time series anomaly detection, also freely available on your data health metrics in open source. But we are continuously releasing, we have an entire team that basically is building out the open source component, which we conveniently also leverage within our clouds for the analyst experience. So there was a bit of a difficult thing to do, because usually when you build software products, you focus on one user. But that doesn't solve this problem. Like, you need to bring these different stakeholders together. So the engineers can work with their command line interface, can work with a Python library, can build this into their Airflow or orchestration. They can go ballistic on this, whereas the analysts gets a much easier experience that allows them to really focus on bringing their domain knowledge into this system. Very cool. Let me give you a quick example. Is this big enough? Maybe add it like this. So this is a data set. Data set is a table or a data frame or a topic when you're streaming data. It's a collection of logical structure of data, really. And by default, we set up out of the box checks on your data. So as you onboard it, those checks are relatively simple time series anomaly detection on your row counts of data. Helpful, because if you all of a sudden see it go ×2, it might be a key duplication. If you all of a sudden see it drop by 70–80% or an unusual drop, it might be because you didn't get data from a certain country or from a certain device, or some certain data feed is broken. Schema monitoring and freshness. So we're doing a freshness is ultimately on a date-time column that indicates the timestamp of whether a transaction, for example, happens. You do the max value of that and you compare that to this moment in time. That distance is how fresh your data is. So that's a very easy one to monitor as well. And that comes out of the box, those three. But then you start adding your logic to it, or the things that you already know. You can also add checks from other systems. You can just point them to us and we'll do the history and the alerting and the incident management around it. There's, for example, checks from DBT in here that an analytics engineer has added. And they're very easy, for example, to, let's see here. Oh yeah, of course, need to log in. Anomaly detection. This is a relatively simple example. Our row count was very normal, and all of a sudden it's 2x, and that alerts. No input required. Like you don't have to tell the system anything. We'll do this automatically for you. So that's a convenient way to get started. And then the logic you can easily add. There's loads of examples. 10% change over time, an order value, invalid order IDs. Well, that's simple. That's all 0. Invalid shipping dates. That's growing. We click on this. We can see the failed rows. So for every metric where we collect the failed rows or the rows that are not conform. And then very soon, after the summer, we'll release automated analysis between passing and failing. So you can see, oh, in this segment is actually where all the problems have originated. Again, to our example, state code equals New York. That's where we've introduced or where 90% of all the missing values come from. A very easy way to help automate, not dissing New York, by the way. Love that city. But that is one tool to really help speed up the process in the end. And the last thing I wanted to show before we can open up for a small discussion is a workflow around these agreements. So we've talked about these data sharing agreements. This is a feature we've released today. So very proud, very happy. We've already started rolling it out at some of our customers. And it's a workflow to set up a data sharing agreement, ultimately. So we'll go through it. I have let's say I'm doing a customer churn analysis. On my logout. Oh yeah, this is another environment, apologies. Customer churn analysis, a bit bigger. On the retail, Snowflake. And here we get into the analyst experience. I can go browse snippets. So let's say we're going to do checks for retail customers. I don't know what I'm doing here as an analyst. The first time I'm coming here. So I open up the snippets. Say, well, maybe there's something around valid. There you go, invalid data. Fantastic. What is my column name? I add my column name. There's auto-completion. I can say this is the valid format. I can start adding these checks. Very easy to do. Let's start with a simple one. Row count bigger than 0. I will just go and test this. And there's some engineering magic happening behind the scenes. This is sent to your private cloud or on-premise as an instruction. It gets executed on the data locally. Only the results are sent back to our cloud. There's no data moving here. There's no risk of any PI or anything. And we see that this is valid, this check, with a value of 551. So that's the actual row count of this table. Underlying this is our open source project that's doing all of this. So we can see the full scan logs. And this is the engineering experience. This is what the engineer gets on their command line, which they prefer, which is much better than a user interface or a UX or a SaaS application for them. It's quite technical, but ultimately you can really always understand if something goes wrong. It's very clear kind of what's happening behind the scenes. And you can build this up. We can start even doing more advanced things, like we can compare. We call these cross-checks. We can compare the row counts. This is within the same data source, but we can also do it with another data source. So if you have a Postgres for an engineer, that's a fantastic feature to, for example, Snowflake. You can compare that each time you run it, that the row count is exactly the same. So we didn't lose any data in that process. So here I can do same as retail, I think orders. There's no autocomplete on this yet, but and that's how you can interactively work with it as an analyst. So with some of our customers, we're now going through trainings of hundreds of people to go and use this. So proof in the pudding will be eating it, I guess, and testing it out and enabling everyone. But and we think this will be a very valuable tool for them to. Yeah, I made a mistake. Yes. Oh, sorry. There's a. We'll get to you.
I just wanted to confirm what we're seeing, and you might have mentioned it, but Is this the agent, the soda agent?
That's doing all the heavy lifting behind the scenes indeed. Yeah.
Okay, and that part is open source or not?
Well, yeah, you can see all the code from it, but it's open, but it's a part of our commercial offering.
I see.
You're not going to have. There's not going to be a lot of features that you can use it in open source only necessarily.
Okay, yeah, thank you.
You're welcome. Retail orders. I'm still looking for my mistake. There's another question in the back. Sorry. Thank you.
Hey, thank you. So I guess you said that you come from Calibra, so I'll tie it to either Calibra Data Stage, right? The data governance platform of your choice.
Right.
In my industry, financial services, because of the regulatory oversight, right, we've spent a decade and a half, right, really building out our ontologies, right, our synonyms, right, from a conceptual standpoint, and understanding that you want to know what? I'm going to boil my information up so that I don't know that on table 1, field name underscores customer, right? Another table in another database, I have the same concept, but I've boiled it up to this data element that now I've built out this business level ontology of customer. It looks like this solution is really focused on, right, what we would, I guess I would call, right, the technical metadata and pointing it towards that. Do you solve the problem of, or do you have it on your roadmap to say, no, let's bubble it up a level and live at the conceptual or the logical space that I can now define, my data element of customer name, and that should never be null, for instance, or that should never have a value of, -99, as Michael was speaking about from earlier today.
I will take that question and bring that into my pitch for the new feature when we launch it. But yes, absolutely. It's a very good. So you ultimately, you don't want to do this on technical level. You have hundreds of your concepts are implemented or represented in so many tables across your landscape. What we don't have here today is the link between your concept and the table. But we are definitely very much thinking about doing that, because you want to write these exactly as you said, on the logical or conceptual level, and then they just roll out across all of your instantiations of it.
I've done the work to define that, right? Let me now, boom, roll that right out there, right? Sure, let me create additional characteristics or define those in my meta model.
Yes.
But that now turns into a data steward businessy type problem instead of going back 15 years to where we just had technology people trying to do it. So you end up with technology solutions, which is you're trying to solve, it seems, right?
Yes. Yeah. So this is for us definitely the area where we want to make it as simple as possible and as automated. And it's just we need to take all of this step by step. Our team is 40, but it's incredible how much effort goes into all of these different areas and make sure that the user experience is seamless. But yes, something we're going to do already very very quickly is that you can say for all data sets that have this attributes or this annotation or metadata piece of information attached to it, apply the checks. And that's already a slow step in that direction. So to do it more, define this more on a higher level. But yeah, you're welcome. Awesome question, by the way. If there's no more immediately, I'll do 2 more steps in this workflow, and then we're done. One of the next steps, so here this is where I think governance is. Traditionally, governance has been very difficult to approach really from a top-down perspective. And I think we all know it's not a priority for many people, and there's 1,000 reasons why not to do it right now for everyone. So that's difficult. The reason why, here, what we're doing is we're implementing data governance kind of principles or thinking in this workflow by design. You don't have to think about it. And that is one of the nice things, I think, to just make adoption go much faster. So when it comes to identify stakeholders, here, and it's weird that it's not showing. It might be because, actually, I don't know why it is. When you write checks on your tables, we automatically check, this is the owner of this table, or this is the person associated to that data set, and therefore we propose it here in this step. We propose them to be involved in the acceptance or approval workflow that goes with this. So I'll just keep it to myself here. We set notifications, maybe on Slack, on Teams. Maybe we want to trigger a Jira or ServiceNow ticket from this directly. That's relatively easy to do. We set the schedule. It's a default one. We hit save, and that's it. This one here is now in agreements. And I think I actually didn't try this up front, so something should always go wrong in a demo, and I think it's actually happening, yes. Usually I get this little bar on top saying I need to approve this. So there's an approval workflow where you can give feedback and start a collaboration. And that's kind of an end-to-end workflow. It's very small, it's very easy, but I think it's a very powerful tool that you can use and implement. And when I think about this, I think about Bob Signer, non-intrusive data governance. And that's for me, yeah, that's just an easy way to get it into the organization, adopt it, and before you know it, you're actually adhering to great principles. Yes, there's a
Up on the internet too, but we'll do these.
I just want to thank you for the overview. Also in financial services and smaller bank, but still there's always interest outside of the engineering team in the building or monitoring of data quality. And so I'm just curious, what is the plan or the roadmap or the method to provide the agreements to an auditor or outside regulators or somebody who's not using the product specifically to write? It looks very intuitive and simple to build this out, but obviously it's complex as well. How do we share this with others who are interested in what those rules have become?
Love that one. So all of these checks, all of them, whether anomaly detection based, or they're all working off the same principle. There is a configuration file, and we use YAML, and that holds all your checks. And you can add 1,000 to them, or you can add one to it and create 1,000 files, it doesn't matter. If the engineer does it, and they implement it in their data pipeline early, because they may want a circuit break, which could be a good use case, they will absolutely version control this in GitHub. Like that's their everything as code. Like that's a very good engineering principle that is, becoming a no-brainer in the data space. Everything that you create here in the cloud is also this YAML file, and we can configure the cloud to point it to a GitHub location where each time a user makes one, they're pushed there. So you have one place. It can do downloads to a zip file and send it over to the to the regulator for review. But the thing that you won't have there is all the historical results, etc. That's maybe something they would want as well. But for that, we have a full reporting API. We can very easily build that out. You're welcome.
Question from the internet, Maarten. What is the recommended approach to integrate data quality and validation tests within the data ops lifecycle?
Right. So the data ops lifecycle is, there's actually a step called testing in data ops, which is fantastic. There's also a step for your continuous integration, and all of those steps should be tested. Like there's no reason not to. The only reason not to is because there were no tools available to do it easily. But yeah, as part of your release process, you should always be running checks. It's like when you're releasing software, you're running an entire test suite of things to make sure that what you're delivering is good and is reliable. So testing is extremely important in data ops, in my opinion. Yes.
You had a slide when you were talking about the contract before we got into the technology, and I really want to thank you. I think the technology here was lacking in the industry, and I see now it's coming up more. So it's great to understand SODA. But my question is slightly different. You work with a lot of companies, and I think you mentioned retail. Retail is, in my head, is opposite to financials, right? We are going to go very fast. We need all this data. Sometimes later we'll figure out how to make it right. Often, like I had some experiences like that. So my question is, organizationally, it's not that simple to get the whole organization, in my experience, to maturity where they, there are people who could express it in the terms of contract. Because there are so many groups involved in it, in a typical organization, from the engineers to consumers, right? As you're working with the different companies, and you see people doing it, do you see any patterns on where organizations become successful at that, and what does it take to get to this level of maturity?
I would love to already have more data points for you, like how this looks like at scale. Even this is, for us, it's a relatively new release. It's actually, this one's today, so. But the contracts you could already do fully in open source. So one thing for sure is where I see companies think about is like every handover point with other teams is a great place to start, is a great place to introduce these. But yes, I think we also still have a lot of learnings to do there as to what will be the best practices in terms of rolling this out, and especially with larger organizations that are very complicated data flows that touch 10 or plus teams. I can foresee that we might need to build specific product capabilities even to simplify that or to make that more comprehensive. But the reality is we haven't come across that today. It's my very open and honest answer. Yes, yeah. Hope that helps. I guess not a lot, but.
It's good to know where the industry is right now.
Yeah. We can add retail's too cheap to buy it anyway, so stick with the banks. Please.
Hi. Maarten, here.
Yes.
I love the simplicity of the tool and the approach. Thank you. I do have a very quick question on the workflow. So the first step of the workflow, you select the data source, and then you write your checks and stuff. At the first step, is it possible to do same check on multiple data sources, or how does that work?
Yes, the first step I'm very unhappy with because we don't necessarily need it. Like we can automate that first step out of it. Only the name you need. But the selection of the data source shouldn't be a thing. Like you should be able to, when you write your checks, be able to just write your dataset name and then see, oh, I have these different data sources that maybe the same name is in. So we're gonna simplify that. But the thinking is, you start always with, in the current implementation, you start with one data source, and then from there on you can go to other data sources. But you cannot make two hops. Like you cannot, in the same file today, talk about also another source of data. It always contains, like the scope of it is one data source, and then one hop to others today. Yeah.
And these hops, can they be scheduled, or manually we need to go back and make those checks and hops?
No, with the hop, I mean, you can do, for example, a cross-check to another data source and compare your data set, for example. But you can only do that so from this data set to source to one other. So that's the limitation. It's quite, I think, for us during implementation, it was a logical limitation, but we'll see how the requirements around that evolve. But it's not the case that in one file today, you can write things about 10 different data sources. We made that scope for a data source just for the simplicity for the user as well, that they don't have to go through a selection of all things and you already lose them in that process. So we really optimized for user experience there. But again, it's an early release, so we might, I'm sure there will be a lot of improvements to make in that workflow. You're welcome.
Another question from the web. Which tools and frameworks would you recommend to implement complex data quality testing logic, i.e. distribution and aggregate function testing?
Well.
Talk about, now that's a softball pitch. Is what
well. Go here. docs.soda.io. And there, you go to SodaCL. So this is checks language. Right, that's the domain-specific language you talked about. all of the, so complex checks, if you don't have something in the language and you need to do it yourself, you basically revert back to SQL. And for that, we have a pattern that's called user-defined checks. It used to be the most popular one because we had very few check types. Everyone was writing SQL in it. But this is, there are multiple ways to express the logic. And the most commonly used one is that you write a query that outputs the amount of failures. And then you monitor that. But aggregates, we have, let me see, metric checks, missing metrics, numeric. Like, there's a lot of statistics that we, there's a profiling component of this, which calculates a whole bunch of statistics. And then on all of those, you can very simply just add this logic. Like, so fixed thresholds, dynamic thresholds, and anomaly detection. So all of these three you can easily add. Again, fully open source, available. You can still get it done tonight. So I wouldn't wait. It's easy to do. So it's, I would definitely recommend this. There's alternatives, but I think our team is, yeah, we've spent an awful lot of time on this just to make it so simple. So I'd recommend to start there. And if you don't like it, join our community on Slack. There's a good amount, 1,200-ish people there today. Everyone's even helping each other out, which is fantastic. I bet you, if you ask a question there, you'll get an answer in probably less than 3-4 hours. So just recommend to start there. That was indeed an easy one. The easiest question thus far.
Questions? Well, you did really well after cupcakes either way, right?
Yes.
I have a quick question.
Sure.
Oh, wait.
I mean, I'm pretty loud. So out of your customers today, what is one of the use cases that you guys have solved that really your team is proud of? That from a business use case perspective that maybe anyone could understand, even who's not technical. Like what's a win that you guys are really, really proud of?
So the first time I look, my arms are the hair. I don't know how you call it, but thinking back of it. So we released it in open source about a year and 3-4 months ago. And we learned that a couple of months later, they were using this in a couple of countries to check all COVID data before. So when all COVID data is reported back into the central authority, the government, because there's a lot of potential problems in that delivery process, our software was used for this. And we didn't know because it's an open source, and all of a sudden we got a call and say, oh, fantastic, you're using it for that, which is, of course, it drives policy making, which is, yeah, it's really cool to have an impact on even, yeah, and we were like, wow. And then there are all sorts of use cases, all sorts of different industries. From customer data to financial services, ESG data is, yeah. But that one stood out, for sure.
Thank you.
Of course.
All right, well, Maarten, thank you very much for a really entertaining presentation.
Pleasure. Thanks, everyone.
I can tell everybody here enjoyed it.